So this is new. I don't think you would have seen this before. This is going to be brand new, but it's very useful. It's a great little trick in general. So I think you're going to see how valuable it is. Okay? And we're talking about the nature of the roots, and look, it says I can determine the nature of the roots with the discriminant. We're going to talk about what the discriminant is. The reason why we didn't do this before is because it has to do with the quadratic formula. Now that we've done the quadratic formula, we can talk about the discriminant. So the quadratic formula is, I'm doing this off to the side, x equals negative b plus minus square root of b squared minus 4ac all over 2a. In the lesson on the quadratic formula, we saw a variety of examples. The first example, this part worked out to 104. What's the square root of 104? It's 10.2. So it's a decimal. And we got decimal answers. In the next question, this same part was 121. And the square root of 121 is 11. And what did we notice about that question? Who remembers? It wasn't very long ago. What did I point out at the end? It was factorable. So because the square root worked out nicely, I could simplify it to a fraction. And you can imagine that that would always work. If it worked out to 9, square root of 9 is 3, then I can actually do the work on top and get a number on top. I'm always going to have a number on the bottom. So it's going to be a fraction. So it's going to be factorable. And then in the last example, what happened? The number, this part of the quadratic formula, the part under the square root sign is called the radicand. It has a name because these are called radicals. And the radicand is whatever's under the square root sign, whatever's the inside part of the radical. It's called the argument of the radical. Okay, it's the radicand. The radicand was negative. And what happened when it was negative? There were no solutions because you can't take the square root of a negative number when you're working in the real number system, which is what we do. Right? No imaginary answers for us. So that means there's no solution. So it turns out that part under the square root sign, the radicand of the quadratic formula, tells us a lot about what's going to happen. And it's even so important that it has a name, and it's called the discriminant. So the discriminant is b squared minus 4ac. It tells us about the nature of the roots. What does that mean? Roots is kind of another way, like it does mean something a little bit different, but we don't have to worry about that. For us, we'll just say it means the answers. It tells us something about the answers to the quadratic equation. It tells us about the nature of the roots, and it's going to tell us how to solve. So it's really useful. Okay, so now we're going to go back and redo those 3 possible outcomes when we're solving a quadratic equation. Did everybody get that down okay? And talk about how the discriminant You don't have to know it by name. I often just call it b squared minus 4ac. Okay, so we're going to look back at these and we're going to identify what b squared minus 4ac tells us about each one, which we kind of already know. If b squared minus 4ac is negative, you're taking the square root of a negative, what's going to happen, right? So that's kind of where this is going. Okay, so let's do the first example as the one where we have two solutions. I'm only going to draw one this time. So it crosses the x-axis in two places. 2 x-intercepts means two solutions. The one picky thing about today is I want you to learn the exact phrasing that I want you to use when you do these specific questions. There's two things we're getting out of today. There's a particular type of question about the nature of the roots that I will ask you on the test. But then also, if you're ever solving, you can use this to save yourself some time. Okay? So, if you are asked about the roots, and this is the case that you have, this is what you are going to say. Two different roots. I'm putting in quotation marks because I want you to say it exactly that way. I don't want you to say anything else. And that means that there are two solutions, as we already discussed. Okay, that's what we call this case. And this happens, so you wouldn't write this part down, I'm just listing it down at the bottom. This happens when b squared minus 4ac, the discriminant, is greater than 0, or in other words, positive. When b squared minus 4ac is greater than 0, or positive, you have two different roots and two solutions. Okay? There's another part to this one. The other ones are a little bit shorter. If b squared minus 4ac is a perfect square, what are the perfect squares? Yeah, I would write it down. Who knows their perfect squares? I'll get us started. 1 is a perfect square. 0 is kind of a perfect square as well, but it's not positive, so we're not going to count 0. 1 is a perfect square. What's the next one? Is 2 a perfect square? Is 3 a perfect square? What's the next one? 2 is not a perfect square. Square root of 2 does not give us a whole number. Square root of 3 does not give us a whole number. What's the square root of 4? 2. So 4 is a perfect square. What's the next one? 9. Anybody else know them? What's the next one? Did I hear somebody say it? 16, good. There's an easy way to do this, right? 1 squared, 2 squared, 3 squared, 4 squared. So what's the next one? Yeah, 5 squared is 25. 6 squared is? Go ahead, just shut them out. 36. Then you got to know these because you got to be able to recognize them. If you don't recognize them, you can do it on your calculator, but it's way better to know these. I feel like people probably know more about this than they're letting on. Next one's 49. 64. 81. 100, 121, 144, 169. That's 13 squared. I'll stop there. If it's ever bigger than that, then you're going to check on your calculator and see if it's a perfect square. You should know most of those, at least up to 10 squared. I think 11 squared, 12 squared, and 13 squared are also good to know. The more of them you know, just the easier it's going to make on you, right? If b squared minus 4ac is a perfect square, then you can factor. Otherwise, you have to use the quadratic formula. So when you're writing your test and you get to the page that just says solve each quadratic equation, and there's 4 of them, how do you know which ones you can factor and which ones you can't? You have to use a quadratic formula. Bam. You check b squared minus 4ac on your calculator. You go, oh, b squared minus 4ac is 36. I can factor. Or b squared minus 4ac is 37. I have to use a quadratic formula. So you save yourself some time and you don't try and factor something that's not factorable. Does that make sense? I hope that makes sense. That's the main reason why the discriminant b squared minus 4ac is so useful, because it helps us save time knowing whether we can solve by factoring or whether we have to use the discriminant. Or sorry, the quadratic formula. Everybody got that down? The other couple of cases don't have quite as much writing. Okay, next one is this. Remember this case where it comes down and touches and goes back up? Just touches at one spot. So one x-intercept is one solution. Now this seems strange, so you have to just memorize this. But what we say in this case is it has 2 equal roots. So that's weird, but that's what you have to say. Okay? So you just have to, I suppose, memorize it, because it's not necessarily intuitive. Seems weird. There's a very good reason why that's the case. We can talk about that after. I'm not going to get into it right now. It's kind of a long story. But there's one solution. So 2 equal roots gives us one solution. So roots aren't exactly solutions, but for us, it's basically the same. How do I know I have this case? B squared minus 4ac equals 0. When b squared minus 4ac equals 0, you have this situation. If required, you say 2 equal roots, but it's only going to have one solution. An example of this, I don't know that you have to write the example down. You can just watch if you want. Would be x squared minus 6x plus 9 equals 0. And that gives me x minus 3 equals 0. Or x minus 3 all squared equals 0. Therefore, x equals 3. This is why we say it has 2 equal roots, because there are 2 brackets, but they're the same. But it only gives me one solution. The same solution twice. So we call that one solution, but we call it 2 equal roots. Okay, finally, this one, I'm just going to do these little mini parabolas because I want to get through this. And remember, this is 0 x-intercepts, which is 0 solutions. And this one is no real roots. So that's a little bit different because we use the word real. But that's important because those ones have imaginary roots. But we don't work with imaginary numbers in this course, so we don't care about the imaginary ones. So we just say, well, it's got no real roots, so it has no solution. And we already talked about this. This occurs when b squared minus 4ac is less than 0 or negative. Everybody got that down okay? Any questions about that? That's just our summary. Now we're going to try a few of these. All right. So, on a test, this question. This is exactly how it will be worded. Determine the nature of the roots of each equation, then state the number of solutions and how you would solve. But we don't have to solve. It's just how would you solve? So this is the one where you need to know those little phrases. If it just says solve, I would encourage you to use the discriminant to save yourself some time. We're going to do some of that in the next lesson. So I'll show you again what that looks like. Trust me, it's going to save you a ton of time, especially if you're doing quadratic formula, because we're going to take those long solutions of the quadratic formula and squeeze it into 2 or 3 steps. It's going to really streamline that process, so you're going to like it, because it's got to be nowhere near as much writing as you would have to do before. So there's one good reason, but another good reason is you'll know if it's factorable and you can factor it. You'll know if you have to use a quadratic formula, and then you can do that. Okay? So, but we'll do that in the next lesson. For this one, we're just doing these kinds of questions. But there will be a question like this on the test. You don't have to solve, but this question is, hey, discriminant question. Use the discriminant. That's what you have to do. Okay? Are we ready to go for the first one? So, again, you can or not. It's up to you. List the A, the B, and the C. And I do B squared minus 4AC equals negative 1 squared minus 4 times A, which is 2, times C, which is 6. That's 1 minus 4 times 2 is 8. 8 times 6 is 48, which is negative 47. Yes?
So would it be no real roots?
You got it. Exactly right. No real roots. And this is what I was saying before, is I want you to write these exactly the way that I write them. The problem is people change them a little bit, and then because you're not used to it, you say it in a way that actually doesn't make any sense or is wrong or something. So I'm not trying to be picky. I'm just trying to help you be successful. But if you could just get used to saying it exactly this way, then you won't have to worry about saying something wrong. And no solutions, and you're done. You don't say how you solve because you can't solve. So that one, you only need 2 statements, you're done. Everybody get that? You don't have to show the subbing in and the solving steps. You can just say b squared minus 4ac equals negative 47. Like you can just do that on your calculator and just say what it's equal to. I don't need to see that subbing in step. But I do need to say the b squared minus 4ac equals. Don't just write negative 47 because it's like, okay, yeah, you wrote a number. Good for you. What is that supposed to mean? Right? So you have to tell me what that number is, b squared minus 4ac. Or you could write me a whole paragraph if you want, since the discriminant is negative 47, which is like, you could do that if you want, but b squared minus 4ac equals negative 47. Therefore, no real roots, no solution. What happened in the next one? All we did was change one number. All we did was change the sign of one number. But if you're looking ahead and if you're thinking about this, you're going to notice the difference that makes. B squared minus 4ac is, again, negative 1.
The interruption. Teachers, this is the last call.
Squared minus 4 times 2 times negative 6. So because the 6 is also negative, I end up with 1 plus 48, which is 49. A little negative made all the difference in the world. Yeah. No, because that was 1 minus 48, which is negative 47. There's 1 plus 48, which is 49. So I think we're good with 49. All right. And what does that mean? So now we got to interpret this. Therefore, two different roots two solutions. And how would you solve? What's the square root of 49? 7. So that means 49 is a perfect square, which means we can factor. Okay? Are we getting how this works? Making some sense? Okay, we got two more here. What's going on with this one? As you're writing it down, you might notice something. Yeah. It's out of order. The x, it doesn't have the x squared term first. Why would this happen? Well, who knows, but maybe you were doing the work and you started with something bigger and this is just how it worked out. Now you want to either write out the a, which is the coefficient of the x squared term, the b, and the c, to make sure you get the right ones, or, as you said, rearrange it and write it properly. You don't have to do both. I also noticed this one has a common factor, so I would probably factor that out if I was actually solving. It won't make a difference to your final answer whether you do that or not. Okay, so we'll demonstrate and we'll do b squared minus 4ac equals 2 squared minus 4 times negative 4 times 4. So I already see that I got two negatives, which is a positive, so I'm going to be adding. So I'm not going to get a negative. Holy cow, we got a lot of 4s here. 4 times 4 times 4 is 64, which is 68. Which is not a perfect square. So therefore, we have two different roots because it is positive. And two solutions, but we can't factor. So we're going to use the quadratic formula. Mm-hmm.
So for it to be, there's the two different roots in the numbers. To get the two equal roots, it would have to be a perfect square.
It will be a perfect square, but that's not why they're two equal roots. Perfect square, good question, this comes up every year. Perfect square means you can factor, that's all it means. Okay? Perfect square means it can factor. So in this case, or sorry, in B, it was a perfect square, but we have two different roots. So now if you're thinking, which I'm sure you are, okay, so then what happens to have two equal roots? Well, that's going to be our last example, so let's go ahead and do it. Okay? So b squared minus 4ac is negative 12 squared minus 4 times 4, because that's my a value, times 9, because that's my c value. Sorry, you're writing down the question. I'm going too fast. And again, you're going to be punching this into your calculator. You're not going to be doing this in steps. But if you're trying to kind of figure out the relationships and see what's happening here, then it can be good, just for our lesson to kind of do it more slowly and write things out. So 12 squared is 144. Folks, this will always be positive because the negative has to be inside brackets. So if you type this on your calculator, negative 12 squared, bam, wrong. It's not negative 144. It's positive 144 because you're squaring the negative as well. So you might think, hey, well, then why is the calculator giving it wrong? No, the calculator is doing it right because you didn't use brackets. If I use brackets, then it will get it right because you're telling the calculator the proper way of doing this. If you did it the other way, you're telling the calculator the wrong way of doing it. Okay? So 4 times 4 is 16. 16 times 9 turns out is 144 again. So those two parts were equal, and I got 0. This is the case where you have two equal roots when you get 0 for the discriminant. Okay? So therefore, you have two equal roots, which is one solution. And again, you can factor. In fact, it's always going to be a perfect square trinomial. So this one is going to be 2x minus 3 squared equals 0. And that's really easy to do. And I'm not going to show you right now, but I can show you after if you want to see it. If you like tricks like this, if you do b squared minus 4ac and it equals 0, figuring out the factored form, even if the numbers were huge, is actually really easy. Okay, so that can be useful. But if you're asked the question like this on a test, state the nature of the roots, how many solutions, and how you would solve, you would say b squared minus 4ac equals 0, and you would write those three statements. That's how you would answer that question. All three are required. Showing me that b squared minus 4ac equals 0 is required, and then that question's done. You don't have to solve. You don't have to factor, generally speaking. Any questions? Are you sure? Now, I know what you're thinking. You're thinking all the way back to grade 9 when you used to solve linear equations. A linear equation is like this: 2x plus 4 equals 10. Subtract 4 from both sides, divide both sides by 2, and you get one answer. And then in grade 10, you bump it up to quadratics. Quadratics have an exponent of 2. It's called degree 2. Right? You remember talking a bit about degrees of things? So quadratics are degree 2, and they can have up to 2 solutions in the real number system. And what you're thinking is, well, wait a minute, what if we went up to degree 3? I know you weren't actually thinking that, I'm just pretending. So what if we went up to degree 3, or degree 4, or degree 5? And it turns out it's true, if you go up to degree 3, you could have 3 solutions. Degree 4, you could have 4. Degree 5, you could have 5. And we look at, in one course in high school, we look at how to solve those kinds of questions, but it's very different from the quadratic factoring. So, it takes a long time. It takes almost a week of lessons to learn how to solve those kinds of things. So we're not going to talk about that. But here's what I do want to show you. Is there a formula for solving degree 3 polynomial equations? Like the quadratic formula solves degree 2 equations. What about degree 3? There is. There's the formula. Easily memorizable, I think, right? Do you think you can memorize that? I don't think I could. Look at that beast. That's the cubic formula. So a cubic, you can see, is ax cubed plus bx squared plus cx plus d equals 0. That would be the formula. As long as it's factorable, you could factor it and solve it that way. But if it's not factorable or whatever, you could use this formula. Oh my gosh, that's insane. This is the discriminant. Oh, no, where's the, sorry. I guess I don't have the discriminant here. I thought I did. What about degree 4? Degree 4 doesn't have a formula, but it does have a discriminant. Actually, it has an algorithm, but it's not a formula. But that's the discriminant. So for quadratics, it's b squared minus 4ac. For degree 4, it's that. Holy cow. Which tells you about the nature of the roots. And then it was proven that for degree 5 and higher, there is no formula. There's not even an algorithm. For degree 4, I believe it's not quite a formula, it's an algorithm. But there's a way that you can solve it. But for degree 5, it's impossible. I don't understand how they proved that that's not possible to have a formula, but they've proven that there's no formula and there never would be for degree 5. So you're on your own. There are ways of doing it. You could punch this into a computer and it'll come up with the solution immediately. So there is math to solve them. There's just not a straightforward formula. Anyway, kind of funny to see how much it changes when you go up. So it's a good thing we stop at quadratics in this course. We only need the quadratic formula. We only need b squared minus 4ac, our discriminant, but it's really useful for quadratics. There is this kind of question that we did today, but then you're going to use it, I think, every time you solve, because why not? It'll save you a ton of trouble. Any questions about any of that?